Now let's take a look at this integral. So we have a rational function. The top degree is lower than the denominator, so it's a proper fraction. No need to go through long division. Now, if you notice this factor, this quadratic right here, it's an irreducible. So you can't really factor that. So you would have to go with setting up the partial fraction decomposition. So I'm going to show you another way to do it, but if you were to start off by using partial fraction decomposition, you'll set it up this way. So you got x squared minus 3x plus 7 over the denominator, x squared minus 4x plus 6 squared. So you'll set this up as two fractions like this. So you'll have, on the first denominator, you'll just have x squared minus 4x plus 6. And the second denominator, you'll have x squared minus 4x plus 6, since that factor is repeated. So it's an irreducible quadratic repeated. So on the numerators, we're going to put linear functions. So we'll have some ax plus b. And the second one, another linear function. So you'll have bx, cx, different coefficients, cx plus d, and so on. So you use this algebraic technique to solve for your coefficients a, b, c, and d, and then you start integrating. Now, I'm not going to do it that way. That's one way to go about solving this problem. I'm going to show you a different approach, which will eventually lead you to the same answer you'll get by solving for your coefficient a, b, c, d. So what I'm going to do, I'm going to try to just write the numerator in a way so that this looks like negative 4x and this looks like 6. So what I'm going to do, I'm going to write it like this. So we know negative 3x. Think of it as this is negative 4x plus x, because that's negative 3x. And then 7, well, I can write that as 6 plus 1, because that's 7. And you'll see why I'm doing that. So what I'm doing, I'm rewriting the numerator. So I got x squared, and then I'm going to write 4x and hold on to the x that's going to come in, and then plus 6, and now write down the x plus 1. So what I have done, I matched my numerator with the denominator right here. And I didn't change the question because all I did was I just rewrote these guys with those specific terms. Now, this is the numerator. Now, the denominator, you got the same thing, x. And once I have rewritten the numerator, now I can separate this into two separate fractions. So we're integrating x squared minus 4x plus 6 over x squared minus 4x plus 6 squared dx plus the integral of the remaining piece, which is x plus 1 over the denominator, x squared minus 4x plus 6 all squared dx. So that's the reason I wrote the numerator that way, so that way now these guys can't simplify because that's treated as the same term. Algebraically, you can cancel them, so you'll be left with 1 over just 1 factor of x squared minus 4x plus 6. Now that integral is easy to deal with. Now the second one, you might have to do a little bit of rewriting, or you can set up another method to solve that. So let me go ahead and just rewrite that. So what I'm going to do now here is I'm going to try to rewrite plus 1 in terms of, so think of it this way. 1 can be written as perhaps negative 2 plus 3. And you'll see why I'm doing that a little bit later when we do the integration. So I'm going to rewrite that integral one more time. So I got x minus 2 plus 3, because that's really x plus 1. And the denominator, I got x squared minus 4x plus 6 all squared dx. All right, now let's take a look at this integral. So we'll do one piece at a time. Let's see how do we work on that one. We're going to complete the square. So if you complete the square, so we got x squared minus 4x. So we take half of negative 4 and we square it. We got plus 4. So I add 4 to here, but to keep it balanced, I minus 4. And then we carry down the plus 6. So then this will factor into x minus 2 squared. Negative 4 plus 6, that's just plus 2. Right, so that's what this becomes. So I'm going to go ahead and do that. So I got the integral. So this integral, you can complete the square, and then this would look like this. So we got this denominator replacing this guy right here. So I just rewrote it so that now we can integrate. Now, if you remember, this is this integral is actually arctangent. So in other words, I can rewrite 2 as a square root of 2 squared. So it is in the form of the integral 1 over x squared plus some a squared. And this integral is 1 over a times arctangent or tangent inverse of x over a plus c. So that's what this integral is, where x is really our x minus 2 and a is our square root of 2. All right, so now that we have done that, so this integral is super easy. So then this is going to be 1 over square root of 2 tangent inverse of x. Well, our x is x minus 2 over square root of 2 plus c, of course, but we're going to hold on to that because we still got to finish up this. So let's hold on to that answer. Now here on the second piece, here's what I'm going to do. I'm going to split this up into 2 separate integral again. So I'm going to group this into one integral and then plus 3. All right, so once we have done that, now this integral is very easy to do. That's a u substitution. So we're going to pick the u to be just the denominator inside the exponent. So we can pick u, let u should be just x squared minus 4x plus 6. Then the derivative of u respect to x is 2x minus 4. And now I want to match this with this piece so that it works. So what we're going to do, we're going to factor out a 2, and then it really works nicely. So you can factor out the 2. So you get x minus 2 dx is equal to du. And that's exactly what we got. We got x minus 2 dx. So I just need to divide by 2. So 1/2 du would be replacing x minus 2 dx. So then this integral now can be treated as the integral of 1/2 1 over u squared du. And then by writing this as an exponent, you can simply say this is u to the negative 2 power. And we know how to integrate that at this point. It's 1/2 u to the negative 1 over negative 1. So it's really negative 1 over 2u. And now plug in what u is. So that's going to be negative 1 over 2. And we said u is x squared minus 4x plus 6. So there you have that piece done. So our answer is going to be this right here plus negative of that. And now let's finish up the last piece. So I'm just going to go ahead and box these so we don't forget them at the end. So this is one of our answer. That's 1. This is the other piece of our answer, 2. And the last piece that we need to finish up is this integral right here. All right, so that's going to be a little bit of work. So I'm going to need a little bit more space. So let's pull this in the bottom. Now this piece of our problem, it's going to be done by trig sub. Now the way we're going to do it is by replacing this piece with when we completed the square. So when you completed the square, that was right here, we replaced it with x minus 2 squared plus 2. So I'm going to go ahead and do that. So when you completed the square, the denominator of this became, so 3 over x minus 2 squared plus 2 all squared dx. Now that's a tangent substitution. So this is your x, you can think of it that way, and this is your square root of that would be a. So I'm going to go ahead and rewrite that as well. Square root of 2 squared. So just to put a little bit more room. So you can think of as this is square root of 2 squared, all squared. All right, so we're going to use x minus 2 to stand for a tangent theta. So you will have a square root of 2 tangent theta. And then dx, it's going to be square root of 2 secant squared theta, d theta. All right, so that's the substitution. So now once you do that, let's come back to our integral, change everything in terms of theta. So we got 3 dx, that's going to be square root of 2 times secant squared theta d theta. And on the denominator, you're going to get x minus 2, well, that's replacing square root of 2 tangent theta squared plus just square root of 2 squared, that's just 2 squared. Let's write it like that. And now if you simplify this, before we can integrate, we have to simplify. So we got 3 square root of 2 secant squared theta d theta. Now I'm going to go ahead and simplify this. So that's just simply 2 tangent squared theta plus 2 all squared. Now this is an identity, so we know that tangent squared theta plus 1 is secant squared theta. So I'm going to replace that here, but I will have to factor out the 2 from both of these right here. So you can write it like this. So a little bit more rewriting so we don't get lost in the problem. So that's the numerator, same as it is. The denominator, I pull out a 2, and then I got tangent squared theta plus 1, everything being squared. And now tangent squared plus 1, this is where I'm going to replace the identity. So I've got, this is the integral of 3 square root of 2 secant squared theta d theta over, so the 2 is being squared, that's 4, and then on the denominator tangent squared theta plus 1 is secant squared theta, square that, that's secant to the 4th theta. All right, now we're ready to simplify this further. So these guys can cancel 2 of the factors, so you will have the integral of 3 square root of 2 over 4 times 1 over secant squared theta d theta. And 1 over secant, of course, that's cosine. So I can simply write this as cosine squared theta. All right, very nice. And now here, we're ready to integrate this. So we're really integrating 3 square root of 2 over 4, the integral of cosine squared theta d theta. And you know when you have even power with sine and cosine, this is how you integrate. We know that cosine squared theta is 1/2 1 plus cosine 2 theta. So that's the identity we're going to use for cosine squared theta. So this is 3 square root of 2 over 4 times, so I'm going to replace it with 1/2. So I pull it out, and then the integral of 1 plus cosine 2 theta d theta. Oh boy, this is looking good now. So let's combine. So 3 square root of 2 over 4 times 2, that's 8. So we get 3 square root of 2 over 8 times, now the integral of 1 respect to theta, that will just be theta. And the integral of cosine is sine. So this will be sine 2 theta divided by 2. All right, now we're putting down our plus c. We're almost there. Now we need to rewrite our answer in terms of the original variable x. So I'm going to go ahead and take my substitution. So initially, this is our substitution. So to bring back the x variable, we go back to this. So recall this from above. So if you solve for tangent theta, you know that tangent theta has to be x minus 2 over square root of 2. Tangent is opposite over adjacent when you draw the right triangle. So let's see what this becomes. So here's our right triangle. And let's suppose theta is here. Opposite length is right there. So tangent is opposite, that's x minus 2 over adjacent square root of 2. That means the hypotenuse will be the square root of opposite square over adjacent square. So it's going to be opposite square, that's x minus 2 square, adjacent square, square root of 2 square, that's just 2. All right, that's our hypotenuse. Okay, so now let's bring this answer, this partial answer right here. So we got, let's distribute the 3 square root of 2 over 8 as well. So you got 3 square root of 2 times theta over 8 plus 3 square root of 2 over 8 times 2, that's 16 sine 2 theta. Now here you might want to apply the double angle identity to rewrite that. So sine 2 theta is really 2 sine theta times cosine theta. And the 2 and 16, I can reduce them as well. So that will be an 8 here. All right, so now we're ready to use our triangle to reiterate what theta and sine theta, cosine theta is. So we know that this is tangent of theta. So if I do tangent inverse, I can solve for theta. So tangent inverse of x minus 2 over square root of 2 is equal to theta. So this is 3 square root of 2 over 8 times tangent inverse of x minus 2 over square root of 2 plus 3 square root of 2 over 8 times sine theta. Well, sine using the triangle is opposite over hypotenuse. So that will be x minus 2 over the square root of x minus 2 squared plus 2. And cosine, it's going to be adjacent over hypotenuse, so that's square root of 2 over the denominator. So I'll put parentheses around square root of x minus 2 squared plus 2. And then we can polish the answer further and write it out. So, but let me collect all my terms. So this is our answer to the third integral. I'm going to simplify it for you a little bit later. So our final answer is the first box right here. That was the first integral. The second box right here. And the third integral, we just solved it on the bottom. So let's collect them. So here's one of our answer. Let's put this down here. That's 1. And then plus the second box we had. So that's right here, this one. This is a negative. And then the last answer is the one we just got. So let me just get rid of these. So the last answer is the one we just got. So I'm going to rewrite it a little bit. So we got plus 3 square root of 2 over 8 tangent inverse of x minus 2 over square root of 2 plus, now here I can combine some coefficients like these guys. I can combine. So 3 square root of 2 times square root of 2, that's just square root of 2 divided by 8, that's 3 over 4. And then we got x minus 2 on the numerator. The denominator, the square roots will cancel, so you'll simply just have 4 times x minus 2 squared plus 2. So that will be in the denominator, just simplifying it algebraically. And you can really do a lot with this answer, but I'm going to stop it right here because I think we have got to the main idea. You can play around with it and make it look different. For example, these are like terms, so you can combine their coefficients. And then if you play around with it, this one and this one, they have same denominator. So you can also join them as well. So hopefully you should be able to do that after seeing how the problem is done.